Welcome to the recording of lecture section 6.6, part B.
We will now compute the derivative of arc cosine using implicit differentiation and by drawing a triangle. Remember that arc cosine is the inverse of the function cosine of x. So first I write down y equals arc cosine of x. And then because I want to work with not arc cosine, I want to work with cosine, I will take cosine of both sides. And because arc cosine is the inverse of cosine, I have cosine arc cosine of x is equal to x. So cosine of x or cosine of y is equal to x. Next, I differentiate both sides with respect to x. So I have ddx cosine y equals ddx x. The right-hand side is just 1. The left-hand side is, first we have to differentiate cosine y with respect to y. So I have negative sine y. And I multiply with dy dx. So now dy dx is negative 1 over sine y. And now I need to figure out what is sine y. And that's where this triangle picture comes in. Now let me go back to this step. So I have cosine y equals x. So I'm going to draw a triangle where y is my angle. And cosine y equals x means that I should write x as the length of the adjacent side. And x is equal to x minus 1. So 1 should be my hypotenuse. And now I can say that this angle here, or this side here, is equal to sine of the angle y. But using the Pythagorean theorem, this side is square root of 1 squared minus x squared. So sine of y is the opposite side, so square root of 1 minus x squared divided by the hypotenuse, which is 1. And so here I have negative 1 over square root of 1 squared minus x squared. And so we are done. So the derivative of arc cosine of x is negative over square root of 1 minus x squared. So this is a technique that is commonly used when working with inverse trig functions. You can see the recommended Khan Academy or the textbook for how to differentiate arc sine. Here is a problem from WebWork where we want to evaluate an integral. And I'm going to explain to you a new technique, which again involves drawing a triangle. So my goal is to somehow convert this integral into an integral in terms of theta, where I'm going to think of theta as this acute angle here. I have drawn these 3 boxes, and I will replace each of the 3 boxes with some expression in terms of theta. So the first step is I will draw my triangle, but somehow I want the sides of my triangle to reflect the values that are here. I see that I have this somewhat complicated looking value, square root of 36x squared minus 1. And what I can see is that because of this minus 1, I don't want to make this value my hypotenuse value. So I'm going to put this value either here or here. But because this is minus 1, I'm going to put this value, which would have to be bigger than 1, to be the hypotenuse. So that's why I have written here, square root of 36x squared equals 6x. And now I have a choice. I can put square root of 36x squared minus 1 down here, or I can put it as the opposite side. And then the third side would have to be 1. Now, it doesn't matter which picture I choose, I will get a correct result. So let me just choose this picture. So once you choose a picture, you have to stick with it and just not use the one that you did not choose. Now I will use this picture to convert everything in the integral into an expression of theta. So first, I see that I have this expression 1 over x. And if I do 1 over 6x, that is similar to 1 over x. So 1 over 6x is the adjacent over the hypotenuse. So this is cosine of theta. So from here, I get that 1 over x is equal to 6 cosine theta. So that's good. So I know how to replace this first square. Next, let me replace this dx. In order to do that, I need to write an expression of x in terms of theta. So I have x equals 1 over 6 times 1 over cosine theta. And from here, I have dx is equal to 1 over 6 times the derivative of 1 over cosine theta. So I have negative 1 over cosine theta squared. And then because of chain rule, I have to do d theta cosine theta. And this is going to be negative 1 over 6, 1 over cosine theta squared times the derivative of cosine theta, which is negative sine theta. And the two negatives cancel out, so I have 1 over 6 sine theta over cosine theta squared d theta. And finally, I need to figure out how to replace this last box. I see that I have 1 over this value. So both values are sides of my triangle. So let me use those. If I do 36x squared minus 1 square root over 1. This is opposite over adjacent. So this is tangent theta. And for what I'm going to do later, it is easier if I write this as sine theta over cosine theta. So that's what I'm going to do. So then this box is equal to cosine theta over sine theta. So that's good. So I have all of the values that I need. So now I'm ready to do this substitution. All right, so now I've done the substitution. I replace 1 over x with 6 cosine theta, and I replace this expression with cosine theta over sine theta, and I replace dx with this expression. So now you might see why I decided to write this as cosine theta over sine theta instead of writing it as cotangent, because I have all of these sine and cosine, and 2 cosines cancel out and the sine cancel out, and 6 and 1 over 6 cancels out. So I have this very nice expression. So when I integrate, I have theta plus c. And now I just need to replace this theta with an expression in terms of x. So from here, I have 1 over 6x is equal to cosine theta. So this gives me arc cosine 1 over 6x is equal to theta, because arc cosine and sine are inverse functions. So now I can replace theta with arc cosine 1 over 6x plus a constant. Now I can also check my answer if I want. So I can take the derivative of arc cosine of 1 over 6x. And we just computed the derivative for arc cosine of x. So that would be negative 1 over square root of 1 minus 1 over 6x squared times the derivative of this value, which is 1 over 6 times negative 1 over x squared. And if you simplify, you should check that this is equal to 1 over x times 1 over square root of 36 x squared minus 1.